The topic we are going to discuss is basic blocks and flow graphs. The question is the intermediate code turns a 10 cross 10 matrix into an identity matrix. Although it is not important where this code comes from, it might be the translation of the pseudocode. In generating the intermediate code, we have assumed that the real valued array element take 8 bytes each and that the matrix is stored in row major form. This is the pseudocode of this question. Here the matrix considered 10 cross 10, then it takes array element 8 byte each, that the matrix is stored in row major form. The pseudocode tells outer loop with a row index starting value I 1 to 10, inner loop with a column index j value starting from 1 to 10. The outer loop starting value I equal to 1, the condition going to be I less than or equal to 10. When the condition is true, it enter into the inner loop, the j value starting from 1 and the condition going to be j less than or equal to 10. If the condition is true, the statement a of I comma j equal to 0.0 is executed. The next for loop I value starting from 1 to 10, the condition is I less than or equal to 10. If the condition is true, the statement a of I comma I equal to 1.0 is executed. Using the pseudocode, we will write the 3 address code or intermediate code. After that, we will draw the basic block and flow graphs. First, write the 3 address code. The given pseudocode, the outer loop with row index I equal to 1. Here you write I equal to 1. The inner loop with column index j equal to 1. Then write j equal to 1 here. The given pseudocode, if outer loop condition is true, it enter into that inner loop. The inner loop condition is true, which means j less than or equal to 10. The statement is executed. What is the statement? A of I comma j equal to 0.0. In the question, they are given 10 cross 10 matrix. Array element takes 8 byte, that the matrix is stored in a row major form. To find the memory address of 2D array element in row major order using the formula address of A of ij equal to I into number of columns plus j into size of element. Here we are using 10 cross 10 matrix and each array element takes 8 byte. So address of A of ij equal to I into number of columns going to be 10 plus j into 8. 8 means each element takes 8 byte memory. We know that I value and j value going to be 1, number of row and number of columns going to be 10. Then find linear index equal to I into number of columns plus j. I value going to be 1 into number of columns 10 plus j value 1. Then compute 1 into 10 plus 1 going to be 11. If 11 element exits before the array and each element took 8 byte, that is 11 into 8, you will get 88 byte. So the first element of A of ij, that is A of first row first column is 88 byte, not byte 0. So we subtract 88 because when I and j start at 1, the correct byte offset for A of 1 1 is 88 byte. Using the temporary variable, we will construct the 3 address code. Temporary variable 1 equal to 10 into I. What is 10 into I? Here each row has 10 elements. Next, temporary variable 2 equal to T1 plus J. Here plus J means move to the column inside the row. Next, temporary variable 3 equal to 8 into T2, which means we will multiply 8 byte. That is each element takes 8 byte in memory. Then we subtract 88 with T3, which is stored into the temporary variable T4. So why we are subtracting 88? For example, imagine you are sitting inside a theater. Seats 0 to 87 already booked by someone. Your group starts from seat 88, but your ticket shows seat number from the beginning of the theater, that is seat 0. So if your ticket says seat 110, then your seat in your group is 22 because you subtract with the 88, that is 110 minus 88, you will get 22, 22nd seat of your group. The same idea is followed in the memory. That's why we are subtracting it. T4 equal to T3 minus 88. Then we store the value A of T4 equal to 0.0. This means put 0.0 inside the memory location that belongs to A of ij. Then move to the next column j equal to j plus 1. That is inner loop get incremented by 1. Now j value becomes 2. After that it check the condition j less than or equal to 10. If the condition is true, the statement is executed. That is, go to third line. The entire statement is executed. If we still have column in this row, go back and compute for the new j. Next, when inner loop finished, move to the next row, that is I equal to I plus 1. If the row remain, restart the inner loop for the new I, that is if I less than or equal to 10, go to 2. If the iteration finished or if the condition is false, it exits from the inner loop and the outer loop get incremented by 1. After that, it check the condition I less than or equal to 10. If the condition is true, it enter into that inner loop, that is go to 2. Next loop for I value starting from 1 to 10. Here the condition I less than or equal to 10. If the condition is true, the statement a of I comma I equal to 1.0 is executed. Here starting value I equal to 1. So write I equal to 1 is the diagonal loop. Then compute I minus 1, which is stored into the temporary variable 5. We know the identity matrix diagonal a of 1 comma 1 going to be 1, a of 2 comma 2 going to be 1, a of 3 comma 3 equal to 1, then up to a of 10 comma 10 equal to 1, because I value going to be 1. So start the diagonal loop, reset I to 1. Then compute I minus 1, which is stored into the temporary variable t5. For diagonal element, the zero based linear index part will involve I minus 1. Start from the first row and the first column. First row I equal to 1, first column I equal to 1. Then subtract I minus 1, which is stored into the temporary variable t5. To find the diagonal element a of I comma I, we want the row number starting from 0 instead of 1. When I equal to 1, t5 becomes 0. When I value 2, 2 minus 1, you will get 1. When I equal to 3, t5 equal to 3 minus 1, you will get 2. After that, compute 88 with I minus 1. When I value is 1, you will get 0. Then T6 equal to 88 into 0 is 0. When I value 2, T5 becomes 1. Then you multiply it with 88, you will get 88. When I value 3, T5 value going to be 2. Then T6 equal to 88 into 2. You will get 176. After that, a of t6 equal to 1.0. We stored 1.0 in the memory location computed in t6. A of 0 equal to 1.0, which means a of 1 is 1. A of 88 equal to 1.0. That is a of 2 comma 2 is 1. A of 176 equal to 1.0. That is a of 3 comma 3 equal to 1. That is a of I comma I equal to 1.0 is executed. Then I value incremented by 1, that is I equal to I plus 1. Then it check the condition I less than or equal to 10. If the condition is true, the entire statement is executed. That is the line number 12 to 15 executed. Before matrix, all the numbers are 0. After running the 12 to 17th line, you will get the diagonal matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Finally, we constructed 3 address code. Now we will identify the leaders using the rules. Rules for finding leaders. The first statement is always a leader. In this 3 address code, first statement I equal to 1 is a leader. Rule number 2, any statement that is the target of a gem label is a leader. The gem target are leaders. That is, if j less than or equal to 10, go to 3. Third line is a leader. Next, if I less than or equal to 10, go to 2. Second line is a leader. If I less than or equal to 10, go to 13. 13th line is a leader. Rule number 3, any statement that immediately follows a jump or branch is also a leader. The given 3 address code statement after any jump is a leader. Here jump statement, if j less than or equal to 10, go to 3. The next statement going to be I equal to I plus 1 is a leader. Similarly, the next jump, if I less than or equal to 10, go to 2. The next statement is I equal to 1 is a leader. So finally, the leaders are 1, 2, 3, 10, 12, 13th line. So these are all the leaders in the given 3 address code. Using these leaders, we will make a basic block and flow graphs. The line number 1, I equal to 1 is a leader. So the first basic block going to be I equal to 1. Next leader, second line j equal to 1. That is second basic block to j equal to 1. Next line number 3 is a leader. Start from line number 3 and go still just before next leader, that is line number 10. It end with a conditional jump. If j less than or equal to 10, go to 3. Then draw the basic block T1 equal to 10 into I, T2 equal to T1 plus J, then T3 equal to 8 into T2, T4 equal to T3 minus 88, then J equal to J plus 1. If J less than or equal to 10, go to B3. B3 means line number 3. Line number 10 is a leader. Start from line number 10 and go still just before next leader, that is line number 12. It end with the conditional jump. If I less than or equal to 10, go to 2. Then draw the basic block I equal to I plus 1. If I less than or equal to 10, go to 2. 2 means second line j equal to 1, which is in basic block 2. Then here you write basic block 2. Next, line number 12 is a leader. It start a new block, no jump here, so it will go to the next block. Then draw the basic block 5, I equal to 1. The given 3 address code, line number 13 is a leader and end with the conditional jump I less than or equal to 10, go to 13. This portion is basic block 6. Then draw the basic block 6, T5 equal to I minus 1, T6 equal to 88 into T5. Then A of T6 equal to 1.0, I equal to I plus 1, and if I less than or equal to 10, go to 13. Who is 13? 13th line T5 equal to I minus 1, which is present in the basic block 6 itself. Then write B6 here. So we draw on the basic block starting from 1, 2, 3, 4, 5, 6. Using the basic block, we will draw the flow graphs. The given flow graph, first entry point, basic block I equal to 1. If a block end normally, then arrow goes to next block in the program. So the connection goes to basic block 1 to basic block 2. Basic block 2, j equal to 1. Then connection move from basic block 2 to basic block 3. If a block end with a conditional jump, like if j less than or equal to 10, go to B3. The connection goes to B3 itself only. Next, B3 to B4, no jump. Arrow goes to next block in the program. Then draw the connection B3 to B4. Look at the B4 basic block I equal to I plus 1. If a block end with a conditional jump, here if I less than or equal to 10, go to B2 is a conditional jump. Then connection move from B2, then draw the connection B2 basic block. So B4 to B5 there is no jump, draw the connection normally. Similarly B5 to B6, draw the connections. Look at the basic block 6. Here we are having the conditional jump. If I less than or equal to 10, go to B6. Then draw the connection B6 itself. Finally, end of the program, that is exit. I hope you all have understood basic block and flow graphs. If you have any doubt, feel free to leave a comment in the comment section. Don't forget to subscribe to my channel and press the bell icon for more videos. Thank you.